Hello students, very good evening. This is Vardurga classes, Viman Nagar, Pune. See, today we are going to take a concept of ICC board 10th standard, and you can say in 10th standard many classes you will get the same topic. Topic is refraction of light, but this topic is total internal reflection. So keep in mind it is a reflection, not a refraction. FRACTION is not FLECTI reflection. Reflection. Now see, this is a denser medium, optically denser medium, and this is optically rarer medium. Maybe this is water, maybe more denser than this medium. Density is larger. When light ray means for total internal reflection, we must know two conditions. Ray should travel from denser to rarer medium and angle of incidence should be greater than critical angle. So, okay, these two conditions are very necessary in case of total internal reflection. It is a common phenomena of light when it travels from denser to rarer medium, it bend away from the normal because we have 1, 2, 3, 4 normals I have drawn here. Now when light travel from denser to rarer medium, it bend away from the normal. Bend away from the normal means it will go this side, this way. Now, when we increase angle of incidence, angle of refraction will increase. So, when you increase angle of incidence, angle of refraction will increase because the velocity of light increases, and you must keep in your brain arrow should be there, arrow must be there, otherwise it will be wrong. So when light travels from denser to rarer medium, it bends away from the normal. Incident angle I1 smaller, I2 is a bigger one as compared to this. As angle of incidence increases, angle of refraction increases. At a particular value of angle of incidence, the angle of refraction goes 90 degree with the normal, and this particular angle of incidence is called critical angle, means it is a limit, up to this point you can see the refraction, that's why it is called critical angle. So angle of incidence increases, angle of refraction increases. At a particular angle of incidence, angle of refraction goes 90 degree or goes parallel with the surface. Angle of refraction goes parallel with the surface. This angle becomes 90 degree and this angle is critical angle. When you increase angle greater than critical angle, the ray band towards same medium and it goes reflected ray. So angle of incidence is equal to angle of refraction because it follows the phenomena of refraction of light. So you can, up to this point you can see the refraction, but this point you can see the reflection of light. So when the ray travel from denser to rarer medium, as the angle of incidence increases, angle of refraction increases. At a particular value of angle of incidence called critical angle, the angle of refraction goes parallel to the surface and goes 90 degrees with the normal. This is the angle called critical angle. When the angle greater than critical angle, it bends in the same medium, follows the law of reflection of light. That is, the angle of incidence is equal to angle of refraction. The incident ray, the reflected ray, and normal lie at the same point on the plane. Okay, lie at the same point on the plane. So this is called reflection of light. So overall, you must I think you can understand now what is total internal reflection, not refraction. When the light travel from denser to rarer medium, it is having property it bend away from the normal due to increase in velocity of light. So when it travel from denser to rarer medium, the incident angle increases and increases. At a particular value of angle of incidence, the angle of refraction goes 90 degree with the normal. This angle is called critical angle. When the angle of incidence should be greater than critical angle, it bend towards the same medium, in the same medium. This is called total internal reflection. Here you can see refraction up to R1, R2 and R3. R3 is 90 degree. So R1, R2, R3 up to the refraction, and after this point you can see the reflection of light. So this is called total internal reflection. I will give some example so you can understand. So if you want to bend light in the same medium, you have to increase incident angle greater than critical angle. And what is the condition for total internal reflection? Ray should travel from denser to rarer medium, and angle of incidence should be greater than critical angle. Now here star twinkles, diamond sparkle. So we can't say star is twinkling. Star twinkling means it is a total internal reflection, because from star light is coming from rarer to denser medium, means whatever the atmosphere, dust particle, atmosphere on the earth surface, that is a more denser, optically denser as compared to the vacuum. So light is coming from vacuum to air, means we can say not air, this is dust particle and everything. So you can say it is a more denser as compared to the vacuum. So in from stars, light coming from rarer medium to denser medium. That's why here no total reflection phenomena applied. But star twinkles due to refraction of light, because refraction of light, because the surface of the earth having different temperature at different time zone. So due to change in temperature, the density of the optical density of the air changes, means refractive index changes. Sometimes light bends more, sometimes light bends less. As the refractive index decreases, light bend less. So the bending different. So the position, relative position of the star changes, and the quantity of light entering in our eye changes. That's why we see star is twinkling. But in case when the diamond sparkle, means the person who is making diamond, he make diamond in such a manner, he decreases the angle of critical angle decreases, so maybe 24 degrees something. So at more than 24 degree or more than critical angle, the ray internally reflected number of times, so we can say diamond sparkle. So in case when you have been asked why star twinkles, you can say due to refraction of light. Why diamond sparkle? Due to total internal reflection, because light coming from denser to rarer medium in case of diamond. In when you see when you in a hot sunny day, you can see water on the road at very far from you, because when light strikes the road, it is very hot, so the air or dust particle above the road goes up, because it goes lighter, so it goes up and the density increases over the road. And when light coming from road to outside, it suffers total internal reflection, so we feel it is a water on the way, means you can see water in the desert, water on the road. These all are the mirage. We can say mirage. So mirage is the example of total internal reflection. Sometimes you can see in cold countries, you can see the ships are inverted, means just reverse. Why? Because if you can see, if it is a ship, can't make ship, so I am making this diagram. So when light coming from this, it will go reflection. So because the density over the sea increases due to very chilled temperature, and when it travel, it is not going like this, it will bend. So you can see this side, this way, you can see the reverse, means just reverse of the ship. So this is also example of total internal reflection. So total internal reflection is the main condition. Light travel must travel from denser to rarer medium, and angle of incidence should be greater than critical angle. So in this question, we can say light is coming parallel to this, and when it is strike at this point, what is the angle C they have asked, and uh, they have asked what is the direction of the path ray. So when you see light is coming like this, it is a 90-degree total. Okay, so it is 90-degree. So it is 90 minus 60, you will get 30-degree. Means this angle is 30-degree, means this angle is 30-degree, because both are similar triangle. Okay, so this angle is 30-degree, this angle is 30-degree. They have asked this question. Now, if the light is coming and its critical angle is given 42-degree, they have given critical angle 42-degree. When angle of incidence is greater than 42-degree, it will suffer total internal reflection and it will reflect it back to the same medium. So it is 60-degree, it will be 60-degree. Now at this point, it will move away from the normal, So this will be the path ray of the light. So this was the concept. We can study better way. So total internal reflection is the optical phenomena, and it is a special type of the concept of refraction of light. So bye bye students. Have a nice time. God bless you all. Study hard. Get good marks.